Hi, my name's Erik Dietrich, and what I'd like to talk about today is some of the new language features for C#6. Now, this came out a while ago, and it's not really news to anyone. You're probably familiar with these, but I want to talk about them from somewhat of a different perspective than maybe you're used to hearing about them. And in this case, what I specifically want to talk about is how they impact writing clean code, compacting your code, keeping it nice and concise and readable. So that's primarily what I'm concerned with, not the nitty-gritty details in the IL and what have you, at least for the purposes of this video. I do a lot of instruction and work on people with people on writing clean code, test-driven development, that sort of thing. And so this is kind of near and dear to my heart. Anything that lets you compact code a little bit, it can be great, and especially if it in general promotes readability. So with that in mind, I'm going to take you through a code base that I have that's a demonstration code base that I've put together over the last several years, starting before these features were out in the language. And so I'm going to show you kind of in the wild how you can take existing code and make it more readable and more compact. The first thing I'd like to point out is the value of initializers for auto properties. And if you'll notice, I'm looking at a unit test class here, and the structure of this class is something that I used to do when running when writing unit tests a lot. I've moved away from it in more recent time, but a couple of years back, this was sort of standard fare. So there's this parent class, and then I actually have a child class that inherits from that parent class to get the state. And the reason that I would do that is to make the test methods more readable. I would have a child class for each method under test, and this was kind of a trick to help organize. I've gone in favor of more semantic namings of late, but nevertheless, that's why you're seeing what you're seeing. So these test methods down here are subject to this initialize method before each test. And they're also making use of this. Now, this is stuff that each of the test methods is going to use in general, but it's a little boilerplatey, and I never realized kind of how much better you could make this, but you certainly can in light of the new language features. So if I take a look at just something simple like this is declared here, but I'm not initializing it actually until this test initialize method. But what if we introduce this new language feature, which is the auto property initializing? So I can do that. And you'll notice at the left here, this is a continuous test running tool called ncrunch that is running my tests for me. So if anything goes red, that means something's bad. If it's green, we're all good. So let's take a look now and see what I can do away with. I probably don't need to declare this anymore, right? And it turns out that is exactly right. It is being initialized up here, so I don't need to specifically call that out in the setup method for this test class. So that is an example of a way that I can easily compact code using this initializers for auto properties. Next up, I'd like to move on to a feature called expression bodied member functions. Basically, what this lets you do is express, say, a get only property as a lambda expression. Again, a lot of the new C# language features as of version 6 are oriented around making the language more compact, easier to write and work with, which I absolutely love. So let's take a look at another example of what we're talking about here. So this is a kind of classic thing that you might see, expressing a get only concept as a property, or perhaps you know what you see down here, there's a quick method. So I'm going to do a couple of more things using the new language features to compact what we're looking at here. So here you have a get only property with this as its return value. So let's reduce that in terms of the boilerplate and make this a little more compact. And whoops, got to get rid of the return in there. So now take a look at what we've got here, and what you're seeing there is this is the DevExpress plugin I have is not used to dealing with this new syntax yet. I need to get an updated version of that. So that's where those squigglies are coming from. But rest assured, this is perfectly valid C#. And all of my tests are passing, and in case you were worried, it does in fact build. So now I can compact that 4-line thing that was already fairly compact and readable. Now I can make this extremely compact and easy to read. And I can go ahead if I want and do the same thing with this method right here. And keep in mind that I have this at 14-point font for demonstration purposes. Normally I'd be using 10, so this line, which maybe seems a little long, actually isn't all that long. So what I've done here is, with all my tests passing and everything, I have now compacted, if you'll recall, this was, probably something like 15 lines or so, and now it's 3. I've gotten rid of this test initialize method, and I have flattened this getter and auxiliary method to just be 1 line each. And so in using it, I have the same kind of readability with the constructs in my unit test, but with far less setup up here. Now at this point I'm going to switch to a different class here and talk about a similar kind of construct, but with a slightly different flavor. We're going to look again at the different way that properties are implemented, but in this case we're looking at a get-only property. And right now this is basically a wrapper for this backing store. So I have this immutable board size. So in case I hadn't mentioned it, our domain here is chess. And so what I'm expressing here is that more or less we always want this default board size of 8. But if theoretically you wanted to use this class to do math problems with a board size of 16 or something, go nuts. The expression here then, so board size becomes this immutable property of the object that's specified upon construction. So we want to say that you can set a board size when you create a board, but after that it's not mutable. And to do that, you've got this backing store, and then you've got this thing that exposes it so we can later query as to what it is. Wouldn't it be nice if we can get rid of that? And now with C# we can, or at least I should say compact it. So what we can actually do is make this a gettable property, and we're going to default it to the default board size of 8. And then here we're going to set, because you're going to be able to modify it here and in the constructor just as you would with a read-only field. And so we're going to do that. Now we can get rid of this board size, but not before we we're going to want to replace all of these guys. Let's see where else he is. Board size. Suppose I could do a find and replace, but not actually sure entirely how many of these things there are. Oops. Any more? Well, let's not overthink it. And I believe that's it. So now we get rid of that, and you see all the tests here are green once again. So this is yet another instance of making things a little bit more compact and readable. And if you'll notice, we could replay kind of what we'd done before in night test by doing this. So there are ample opportunities for making things more compact. And there you have it. Now this should all go green, and kind of all in the pursuit of making things a little bit more accessible that way. All right, now I'm really going to kind of switch gears as I switch classes. This is something that has nothing to do with properties or Lambda expressions or anything like that. This is, for those of you who are maybe transplants from Java, this is something that's been in this language, in Java for a while, but is new in the C# world. And this is the using static construct. And what I'm going to do to show you here is you've got a couple of methods, and you've got this innumerable range that you see over and over again. And for our purpose here, from a clean code perspective, at least in my opinion, this innumerable dot is just kind of noise. It's not really helping with readability at all. And previously, we just kind of had to live with it, or maybe you would write some private static method in the class as kind of a wrapper. If you were so inclined, that's a little high ceremony, but what we can do now is say that we want to do using static, and we're going to say system.link.enumerable. And that is going to give us access in this class to call these things without actually specifying the class. So basically, and you can see how the IDE helps you out here. Now it's showing you that this isn't necessary. So if I go through, I can compact the code a bit and get rid of this noise word here. And this is particularly handy in situations where you have a lot of the noise word over and over again. So instead of, you got a kind of a comparison here, we can say this x coordinates to check is range versus enumerable.range. And so I would go throughout this class and remove all the enumerable.ranges that just weren't contributing to readability, and were instead, you know, like here, sending this off the line. Now I could do the same thing with board coordinate 4. I personally wouldn't be inclined to do that in this class because board coordinate 4 was designed to be nicely readable and roll off the tongue. So I would leave that one alone here. But you get the idea. This is also great in classes where you're doing, I won't actually do it, but a lot of math operations. Using static math will give you, you know, you don't need to know that it's math.abs. Abs will give you the idea. So that is using static. To show you the next new language feature now, I'm going to go back to the board class. And there is a method down here in this en passant section that says if en passant, if set en passant if pawn exists at target. And what we see in here is something that you actually see pretty frequently. And the new language feature that addresses this is one that I kind of advise using with caution because it lets you conceal what are called law of Demeter violations, which in short form is basically when you have x.y.z, when you're kind of pawing through objects to get to their sub-objects and their sub-objects in your object graph. That tends to introduce dependencies that can be problematic. I would kick myself if I didn't explain that first. That said, there is a certain niceness to a new language feature that is offered, which is the null conditional. And you see a lot of things of this form. I'm going to get a piece, and I'm going to try to do this gentle cast to pawn. So it is entirely possible in this code that if this piece is not a pawn, target pawn is going to be null. So in order to proceed, I first need to do this check, and then if this check is successful, I go ahead and, you know, do what I need to do. Now, you'll notice, I just want to show you that if I take this check out, bad things start to happen. If you see down here on the right, Ncrunch is telling me that this has caused 6 unit tests that we're passing to fail, probably throwing null reference exceptions. Sure enough. So let's put that back. We don't want those failing tests. But what this new language feature will let me do is instead of doing this check, I can bake it in to the call, and I can say that, oops, I can say basically, if this is null, then you're done. So in this case, we've got a void concept here. But if it's not null, then go ahead. And like I said, you may want to use that with caution, and you may want to read more about it and all the particular edge cases and whatnot. But the gist of it is, and the thing to be aware of, is this can compact a lot of noisy null checking that you might have to do. When you have a lot of defensive programming that has to happen, this can be great for keeping your code compact and readable. All right, on to the next one. And this is one that I absolutely love from a readability perspective. And in this case, what we're talking about here is called string interpolation. And string interpolation basically addresses this bit of syntax that has been in the language for string format. Probably if you've been doing this long enough and you remember C and C++, you have, you know, this evokes memories of printf, where you have some wildcard placeholder in there, and then the first argument to this method is basically the string, and then based on how many wildcard placeholders you have, this tells you what the other two arguments are. That is very kind of old-timey procedural, and it's pretty awesome if you ask me that the language now has this in it, which allows you to do something that is entirely more readable. Now, if you'll notice what happened here, this suddenly is not highlighted red like the rest of the string anymore. This became a different thing altogether. And what this became is an actual ability to bake things right into the call instead of having them in there later as arguments. So right now at the moment, if this were compiling, it would be giving you the literal one. But what we actually want are these other things. And so we'll get rid of that end parenthesis. And this check, which is actually a unit test utility, is still behaving as expected. So what you're able to do is actually just inline these code expressions into your strings if you escape it with this. If not, it will just print this text. So you need to have the literal in there doing the escaping, and that is string interpolation, which I don't know, I think it'd be hard to argue with, in my opinion, that what we had before, going back, this, where you have to look up 0 and then go over here and then 1 and then over here, I think you'd be hard-pressed to argue that that is more readable than, than this. And that is string interpolation. Now I've got one more trick to show you here when it comes to readability, and that is subtly different than these other things in some ways. And the thing I'm going to show you is this name of expression construct. So if you'll notice here, I'm doing something that's pretty common. If I have this verification construct to check the arguments to methods to make sure preconditions are satisfied. In this case, I'm going to say, well, I don't want this piece string to be null. If it's null, I want to throw a null argument exception. And if it's empty, I want to throw an argument exception. That's a pretty common thing to do in the language. And probably, most people are going to think to themselves, well, this is perfectly satisfactory. But there's something here that's always bothered me. And for me personally, this is the concept of runtime binding, which means you're doing something interesting. You are getting this variable name piece, and you are implicitly binding it to this string value piece. And this is an idea that's kind of common in language. It's something that you see in a lot of schemes where you're doing like markup binding or what have you. You are marrying variable names to string literals, and then you're depending on things not being misspelled. Oops. Now, if you've got something that is actually trying to sync these things up, like if you're a WPF developer or something and you're doing this with XAML, you have some idea of the misery that can be caused by accidentally misspelling a variable name in a string that represents that variable name. So like I said, this is not so much about the code readability, but it is kind of a aspect of clean code that revolves around cutting down on errors. We now have this construct that in the language lets you sync this up at compile time. So this name of piece is actually going to generate this string as a string, and that is what you're going to see in this exception. So if I were to actually run this, what you would see is argument null exception, and the argument would be the string piece. So I'm going to replace that here as well. And that is something I highly recommend that you do instead of depending on these things to stay synced. Because if, for example, we go back and I were to change this to something that's not piece, well, this now is sort of nonsense, and it's going to be confusing. So it depends on the person who is actually implementing this to say, oh, okay, I changed this variable name in a refactoring. Now I have to also remember to change this string. When you, oops, now I lost it. When you do this, I'm going to say name of piece. Spelled name of wrong. So if I do this, and then I do this, and then I go to do a refactoring, see, now I'm going to get everything. If I do this, I don't have to worry about that problem any longer. So I highly recommend using this particular construct when you're throwing exceptions or kind of doing anything with the name of an argument. If you're doing iNotify property changed or what have you, by all means, I endorse using this name of construct. And that's going to do it for what I wanted to demonstrate today. This is not an exhaustive list of the new features of the language by any stretch. It's just intended to communicate how, as somebody who does a lot of work around automated testing and cleaning up code and assessing code, it's my experience of how these new language features make your code a lot more readable, a lot cleaner, a lot more compact if used properly. So I wanted to take some time and share that. I am going to make this available on GitHub. The actual repository itself is already up there, but I'm going to create a branch, and you can go check it out on GitHub if you want to see the before and after of this. So thank you for watching, and happy coding.